Now that we have learned how to secure our transport channel, we should look into improving performance. Presently, our application is hosted in the US East region. However, if we have customers globally, someone accessing the app from Asia, Europe, Africa, or other distant locations would experience increased latency. This is because their requests need to traverse long distances to reach our application, potentially slowing down the user experience for those outside the US East region. Amazon CloudFront is a fast content delivery network or CDN service provided by AWS. It securely delivers data, videos, applications, and APIs to customers globally with low latency and high transfer speeds. CloudFront is designed to integrate with other AWS services like Amazon S3, EC2, load balancers, and Route 53. CloudFront leverages a global network of data centers referred to as edge locations, situated around the world. When a user makes a request, it is directed to the closest edge location. The request then travels through AWS's high-speed backbone network until it reaches the region where the original content is stored. This efficient routing process significantly decreases latency and enhances the speed of access. Amazon CloudFront's caching mechanism is a central feature of the service, enhancing the speed and efficiency of content delivery to end users. When a user requests content like a web page, image, video, etc., the request is routed to the nearest edge location. If the content is requested for the first time, CloudFront retrieves it from the origin server and caches it at the edge location. Subsequent requests for the same content are served directly from the cache, significantly reducing latency. By caching content at edge locations closer to the user, CloudFront reduces the load on the origin server, improves page load times for the user, and handles traffic spikes more effectively. Amazon's CloudFront cache encryption enhances the security of content delivery by ensuring that the cached content is stored securely at edge locations. The encryption features of CloudFront align with various compliance requirements, making it suitable for delivering sensitive content. Direct requests to a load balancer can be vulnerable to distributed denial of service or DDoS attacks. However, using CloudFront provides enhanced security measures, including seamless integration with AWS Shield, which offers robust DDoS protection. In order to use CloudFront with our load balancer, we have to make a few changes to the way we have already configured our infrastructure. First, let's go to Route 53 and our hosted zone. We have an A record for www.cloudenthusiast.academy pointing to our load balancer. Because we will be using this record with CloudFront distribution, therefore we will change the DNS name of our load balancer to server-alb instead of www. Let's make that change and save it. Let's verify if our application is responding to this new domain name. However, when we try this domain with HTTPS protocol, we get a warning. Reason being that the certificate is issued for www subdomain, whereas our load balancer subdomain is server-alb, which is a mismatch. Therefore, we have to create a new certificate for server-alb subdomain and attach it to our load balancer. We will follow the same process as our certificate manager session and create a new certificate and validate it. Once we have a validated certificate, we can go back to our load balancer and edit its HTTPS listener. Under Secure Listener Settings, the drop-down will now show two certificates. Select the new one we just created and save changes. Let's make sure we do not get any certificate error this time when we use HTTPS protocol to communicate with our load balancer. Next, we will open CloudFront by typing it in search and selecting the link. This will open the CloudFront dashboard that will not have any distribution. So let's create a new distribution. During the process, we have to provide the origin domain, which in our case will be the host name of our load balancer. So type server-alb.cloudenthusiast.academy. We should select the HTTP to HTTPS redirect option. That will restrict our application to respond only to secure traffic. For most applications, you would need to select the get head, options, put, post, HTTP methods, so select that one for now. For caching policy, select caching optimized, and for origin request, select all viewer option. Under alternate domain name, type www.cloudenthusiast.academy and select the SSL certificate. Keep rest of the defaults and click Create Distribution. It will take about 10 to 15 minutes to distribute this to all the edge locations. While we are waiting, we can go to Route 53 hosted zone and create a new record for www.cloudenthusiast.academy that will point to our CloudFront distribution. In the Route Traffic dropdown, select CloudFront and then select the distribution we just created. After that, click Create Record. Let's go back and check if our distribution is deployed to all the edge locations, which it did. Let's go ahead and type in the https://www.cloudenthusiast.academy domain in browser and verify our application to be working as expected. The load balancer is also responding to both HTTP and HTTPS requests, which is a problem. In future session, we will restrict traffic to our load balancer to only come from CloudFront so that we are able to maximize performance, caching, and DDoS protection. Thanks for watching and stay tuned for more.